The one thing we didn't change is our opening speaker. Not only is he the CEO and founder of TriTech, but he's not a bad speaker. I don't know if you've had a chance to listen to Chris before, but he's pretty thought-provoking. And today he's going to throw out big data and kind of the challenges that we face. And while you're listening to him, think about how you can help us. I mean, we're number one in this industry. We can say that. I mean, in this last year, we've really just taken off. We're winning a lot of good deals out there. The reason why? You guys. You guys push us. You push us to make sure that we provide solutions for you, that you can do your job best, and that's protecting the citizens of this United States. So we need that kind of help. We need to be pushed. We need to, and as we get into this new big data kind of a new approach to how we can go after the bad guys, we need some ideas because, we've got some answers, but a hell of a lot more questions. So please help us. And if you see Chris in the hallway and as you see this presentation and you get an idea, stop us. Stop one of the product managers and let us know what you think. Okay? So, it's my pleasure to introduce our CEO and founder, Chris Maloney.
Appreciate it. All right. By the way, that's Chris McAllister, our Vice President of Marketing and Product Management, if in case you guys have never known Chris. I loved it that he was orange on orange. I've never seen you orange on orange. It looks good. Chris has a way of dressing at the office that inspires us all. His color is orange. He wears orange underwear, I'm told. So, welcome, guys. I'm really excited about this year. It's the largest attendance of any TriCON in the history of the company since I think our first one was in 93, 94, somewhere around there. So obviously we've grown a little bit. We have quite a few more customers these days. And again, thank you. I want to echo what Chris was saying. It really is all about you guys. We can't thank you enough for what you've been doing day to day and today. So what am I going to talk about? This is a topic that some of you may have heard of. Who's heard of the term big data? Raise your hand. Okay, a few. So this is probably one of the most overhyped Silicon Valley trends of the decade. And I say overhyped because it's the largest growing population of new companies that are entering into the fold in technology right now. It's one of the fastest growing sectors. And I think the problem that I have with it is I think it's very deceiving what they've been talking about in terms of big data. Some of it makes a lot of sense and some of it doesn't. But I think that some of the companies that are starting to do big data, they're all about showing you this picture, which is you at the top and all this weird stuff below you that you may or may not know is there, and you certainly don't know what to do with it. So I thought it would be a great idea today to sort of walk through what is big data and what does it mean to you guys. And I'm going to give you a lot of examples as we go through the conversation that are having nothing to do with what you do. So I need you to be patient with that. And the reason is we're not doing big data in public safety yet, at least not in a big way. But I think you'll be a little bit surprised when you reflect on the things that we are doing in public safety that are big data-esque. And we're certainly preparing ourselves for the day when we're going to be doing big data. So let's talk about data in general, okay? You guys all have personal computers. We have servers that are housing a lot of data. This is just a chart, kind of an eye chart about how data is growing. And I'll talk in a little bit about where it's growing, but if you just think about where we were a few years ago, right? We were talking on our PCs, megabytes, right? Now we're talking gigabytes. So we all have several gig hard drives on our computer systems, right? So what's a terabyte? That's this new one over here. Every day, 500 terabytes of data are added to Facebook, okay? What does that mean? It's a lot of data, right? But now what they're talking about is these other things that we're going to actually start to know the names of, right? I mean, how many people knew what a terabyte was way back when? All I knew was a gigabyte, maybe, right? Now we're talking exabytes, and my favorite is the Bronto byte in the upper right-hand corner. I just want to see a Bronto byte. Wouldn't that be cool? Sounds like a dinosaur. And then there's the Star Wars memory, which is Yoda byte. But this Yoda byte is supposedly the digital universe of today. In other words, that's how much data is out there. Well, that's really hard to even conceptualize, right? What is all the data that's out there? Where is it? Well, it's very difficult to figure out how much data is out there. Google did a study, I think it was in 2010, where they estimated the amount of data that existed in the data universe, and they came up with something similar to that. 250 trillion DVDs, okay? That's like lining those DVDs up, going to the moon and a quarter of the way back. It's a lot of data, right? So if you walk through just the things that we really do today, right, which is sort of in this exabyte era, that's really what we're seeing in the internet, okay? This is the amount of data that's being contributed to the internet on a normal basis, and it's accelerating at a very rapid rate. So let's just talk through some of the different products or services that are out there and how much they're storing on a regular basis. Anybody know how many Facebook users there are in the world today? Throw out a number. How many are there? Facebook users. 1 billion? How many people are there in the world today? Okay, 7.1 billion. There are actually 1.2 billion Facebook users today. Okay, now some of those are inactive. Okay, but there's still 1.5 billion Facebook users, right? 1,700 tweets every second. Every minute, 72 hours of video are uploaded to YouTube. Every minute, okay? Now, if you're like me, and when I first started to hear this stuff, you're like, so what? It has nothing to do with my job, right? Facebook, Twitter. How many of you were here last year when I talked about social media integrating into public safety, right? It's here, and we do need to care about it because it's very important. And I'm going to walk through why I think it's important. So let's talk about some examples of the big data universe, but I want to first start by talking about what small data is, okay? We all know what small data is because this is the world we live in today, okay? Not just in public safety, but really on a normal basis in your normal life, you're dealing in a small data world, right? Most of what we're looking at is in silos, okay? We have applications that do things for us that are very siloed, right? We have a dispatch center that has its own database. We have our mobile systems in the car, which has field data collection systems that we're contributing data into an RMS system, which has its own database. And then on the far right, and these aren't the only things that we have, but we have a patient care reporting system. Same thing. We're collecting data about the treatment that we gave to the patient, and we're storing it in its own database, right? The good news is we have a suite of applications all from one company that knows how to interrelate to each other. So we know how to take data from the call-taking system to the CAD to the RMS, marry it with the patient care reporting systems, and everybody's happy because that always works 100% of the time. Okay? Trust me, because I already had breakfast conversation about that. So that's okay, right? I mean, this is what we do every day. It works pretty good. We take calls, the officers fill out their reports, we run calls, we fight fires, we save patients' lives, we record what we did, we put them into the hospital, we book people into the jail. It all kind of works, right? Sometimes it doesn't, but most of the time it works. But here's the problem. If you think about it from an analytics perspective, right? So now start to transport your mind into the big data world and start to think about what could I really do with all that data? So today, if I want to find the phone number of a local hospital, where do I go? I go to CAD. I know it's in CAD. So I go to the search screen in CAD, I go to the phone book, and I pull out the phone number for Mercy Hospital. Good, I know where to get that. Now what if I want to know the phone number for an officer? I need to call an officer on his cell phone. How do I find that? Well, I go to the personnel file in CAD, and I pull that out. I know how to search for that, so it's okay. Now what happens if I want to look up how many times I've been to an incident for a particular address? How many times have I been to a particular address? Oh, okay. I have a search screen in CAD. I go in, I put in the address, I hit search, it pulls up all the incidents that I've been to, right? That's cool. Now what if I want to know how many arrests occurred within an area within my community? Where do I get that? Oh, I got to go to RMS, right? Now I'm in the middle silo. What if I want to find out how many times I gave first shock to a patient? Oh, I got to go to the other database, right? So you see what I'm talking about the silos, right? It's okay though, because we're expert users of these systems and we get it. But that's not ideal, that's not optimal, right? Because one of the biggest problems is I'm only asking very simple questions, right? I'm asking, where did this happen? Who is this suspect? What's the perimeter of this fire? How many vehicles responded? How long was the duration of the incident? How many calls did I have last month? Is my call volume growing or is it shrinking? What's my response times? These are good questions, but they're very simple, right? But that's where we live today. That's most of the questions that we have to ask ourselves today, right? So let's talk a little bit about really sophisticated analysis, okay? Because I want to ask some more complicated questions. I don't want to know what's happening today, and I don't even necessarily want to know what's happening yesterday, right? I want to ask a question like, has the quality of life in my community improved in the last year as a result of my efforts in my agency? How many of you could answer that? Because really, that's what we're here for, right? Yeah, we fight fires, we save people's lives, we respond, we catch bad guys. But really, in the end, public safety only exists to improve the quality of life in our community, right? But we can't even answer that really basic question. And I'll be honest, I have no idea how to answer that. But I have a feeling we're going to find out how to answer it. And that's where big data comes in. So let's talk about the next evolution in big data. And this is good news because we have this today. So the old siloed thing is going to go away. What's replacing it is something that's been around a long time. It's called the data warehouse. So we're not going to have the data spread out into all these different databases. We're going to put them all into one big database. Okay? Why? Why do I care? Well, because asking these siloed questions is very difficult. But if it was all in one place, I don't have to know where I'm looking. I just want to look for anything at this address, anything with this name. Who is John Doe? Tell me anything about these things, right? Name something that we use a lot that is like that today, outside of public safety, where you could just ask a question and you get information right away, and it's free. Google, okay? Google exists to help you find stuff, right? It's a big database. This is like the biggest big data thing ever, right? Google continually crawls the world to help you figure out where to find stuff. That's all it does. It's very simple. It actually exists to advertise to you, right? That's really why Google exists. So, okay, so let's talk about the data warehouse. Well, if you look inside the data warehouse for us, it looks like this, okay? Inform IQ. So IQ, you're going to learn even more about this today. Now I'm going to pitch you a little bit, but I think you'll get it why I'm doing it in a second. IQ is big data. At least it's the start of big data, okay? What we did with IQ is we took all of the databases that we have, literally every product in the TriTech bag, everything from the telephone call from our 911 system to CAD to records, EPCR, all of it goes right into one database, okay? And by putting it there, we get this great advantage because now we don't have to think again about what we're looking for. So let me give you an example. I want to look for a phone number. So if you can see, we typed in a phone number up at the top and we just hit return, just like Google, right? And what I get is a list of things in my database. Again, very similar to Google. What did I get? I got a person, I got a master person record. I actually can get confinements. I can get CAD calls. I can get anti-alley records from here. I don't care. I'm just going to get everything back that has anything to do with that phone number. Now, an interesting thing is if you look at the phone number fields, right? Some of them are phone numbers of the person. There's actually an employer phone. So I didn't tell it where to look. I just said, find me anything to do with this phone number. So let me give you another example. Another IQ search, I just literally entered the word front, okay? I'm really looking for Front Street, but I didn't want to be that specific. So I just entered front. And it did the same thing. It gave me a person and 3 locations, and this is actually a call record, a civil record down at the bottom. Now this is even more interesting because, again, I didn't tell it to look for front in the address field. I just said look for any record having to do with front. So what I get is a person named Front, F-R-O-N-T-E. That's interesting. If you look at the address of these middle ones here, I get 3 locations on Front Street. And then the civil, check this out. Front door, front door, front door. That's a narrative. So this isn't just searching for fields, it's searching inside the fields in the narrative to pull out the word front. It also doesn't even care if it's the full word front, it looks at any derivations. So it'll do things like stemming. If I type in stab, it'll find stabbed, stabbing, stabber, right? Just like Google. Now, it's not perfect. It has a lot of room to grow. And there's a lot of things we need to add, but you can see where we're going, right? I don't want to know where to search. I just want you to give it to me. I mean, I'm a Google consumer. Give it to me. Okay? This is just the start. Okay? This is a very simplistic big data start. But that's okay. It's a good start, right? Make sense? Okay. Who knows what this is? Anyone? Who said that? Oh, cheater. That was a TriTech person. It's the internet. That's what the internet looks like. Isn't that cool? Somebody with a lot of time on their hands. Did you ever see that commercial where the guy is at his computer and he looks all terrible and he gets to the end and he goes, I reached the end of the internet. And actually comes up and says, you have reached the end of the internet. So it's interesting because this is what it really looks like if you get down to the nodes, right? What are those? What are those numbers? IP addresses, right? So every one of those endpoints is a computer or a device, right? So really the internet is not the father of big data, but the transporter of big data, right? The internet allowed us to sort of create big data because it made it possible for us to get from any database to another and contribute data up to the internet and then query data out of the internet. Okay? So it's kind of the catalyst for all of these big data plays like Facebook and Google and Twitter and Yahoo. All of these things are possible because of the internet, right? So let's talk for a second about one of those. This is Facebook. 2004, Facebook launched, right? All of a sudden, we started contributing different kinds of data that we never thought of before, right? With Facebook, we started contributing things that were what we call unstructured, right? If I look at a typical RMS record, and let's just talk about a call for service record, right? When I have a call for service record, it has all these fields, right? So I know what those are. There's an address field, there's a suspect field, there's a caller name field, there's a caller phone number field. That's called structured data. Structured data is really good because we know what it is. We can search it really easily. I can say, look for a call for service where phone number equals this. And the systems know really easily how to get to that, okay? Well, what happened here? This is totally unstructured data, right? So what I have is photographs, videos, posts, texts. I check in places. So we have context for it because I know the person that I'm looking at, right? I can say, this is Chris Maloney's Facebook page. So I know that it has some context for me. I can friend Chris Maloney. He can friend me. He can reject me. I'm really fond of unfriending people. I actually wish they would change it so that they would tell them that I unfriend them. So what do you do with all that, right? There's 1.5 billion people that are putting data into that horn every day. What do I do with that? Well, today we do social media with it, right? We talk about it and we share and we do all that kind of stuff. But is there a data play there? The first problem is I don't know where to look for the data. I don't know how to make sense of it, and I have no idea how to draw conclusions from that data, right? This stuff goes into a database, okay? All the Facebook stuff and the Google stuff and the Yahoo stuff and the YouTube stuff, it goes all into a database. You should be able to search it, okay? That's really what big data is, okay? It's not putting in all of this data into a data warehouse. It's taking this stuff that we're calling unstructured data and figuring out how to search it, okay? How can I search a photograph? How can I search a video? How can I search text? How can I search a narrative, right? That's really what big data is. So let's talk about that, what that really means. So there's a couple of fun things that I'm going to show you that don't, again, have necessarily a great application in public safety. But I want you to start to think about this, and I want you to start to think about how you could apply these concepts, okay? Here's one of my favorite ones. This is a Twitter graph, okay? This shows you what time of the year people tend to break up with each other, okay? So you can see, it's pretty interesting, right? So, all of a sudden it kind of ramps up from the first of the year because everybody's partying and having a good time. And then it comes to Valentine's Day, kind of hits a peak, and then falls off a little bit. And then there's like the spring cleaning, right? I have got to get this woman out of my life. I've got the rest of the year. I procrastinated long enough. It's time. So there's a peak, and then everybody gets a little tired. And then this is my favorite. April Fool's Day. April Fools, we're breaking up. Right? What's up with that? So, and then look at the little peaks there. It's like Mondays. Everyone breaks up on Mondays. You know, I'm kind of tired after Monday. I don't want to break up on Tuesday. Then the summer holiday, because I leave. I got to go on holiday. You're just dragging me down. And then it's kind of a lull, And then, and then people are like, you know, it's just too hard at Christmas. It just seems mean to break up at Christmas, right? And then right before the first of the year, winter holidays, let's break up. How the hell did somebody get this? Well, that's what's so crazy about Twitter. This graph and the other stuff that I'm going to show you, you don't even have to log into Twitter to get this. Twitter has an API that you can just go there and get this data. The interesting thing about Twitter is Twitter obviously has text. It has hashtags, right? And remember how many tweets there are going out every second, right? All of this data can be analyzed in ways that I never even thought about, right? It's not just the text inside the tweet, it's the location. When you tweet, it sends up the location that you tweeted from. It sends up the information about who you are and who you tweeted to and who picked up your tweets, right? Such a silly word. This person did not even log into Twitter to get this graph. I've seen some scary graphs and some relationship graphs like this, where, again, this is a product. It's called a relationship browser. And you can go onto Twitter and you can plug in a person like Steve Campbell, and it will show you all the relationships in Twitter that Steve has. It'll show you sort of his circle and a broader circle, and then it even goes out and shows you people and what their circles are. Okay? Are you thinking? Thinking you might be able to use that? Yeah. Again, you don't even have to log into Twitter or have a Twitter account to get this graph. Okay? That's a little scary, I think. I'm not tweeting. You guys do it though. Go ahead. Because we want to know how you're feeling. And we will too. Here's another great one. What's that? Anyone know what that is? That's the United States of America. That is not a map. That is not a map. I swear to God, it's not a map. Anybody want to guess what it is? Looks like a coverage map. Nope. Who uses Flickr? Anybody use Flickr? Flickr is one of those sites where you can take a photograph and upload your photograph to Flickr and then share it with your friends, right? This is not a map of the United States. This is a map of Flickr photographs that were taken by location. There's no map underneath that. Isn't that wild? This is a terrible graphic, but that's Michigan, right? And literally, this is just people taking photographs and then using a tool to plot them on the map. Okay? Could you use that? I'm thinking you could, or at least something similar to that, right? So now you're starting to see how big data can weave together things that we never thought possible before, right? Let's do an example of another industry that is doing really great things with big data. UPS is kind of the poster child of case studies in big data. They've done a lot of work over the last many, many years. They have a 400-person operations research department that does nothing but study how to be more efficient. So they've created incredible tools. One of them is called Orion. They have 50,000 vehicles that are hooked up to Orion. Monitors all of the things inside the car, including the engine performance, fuel efficiency, number of miles driven, all of the GPS feeds, speed, direction, location. All of it gets transmitted in real time up to the UPS data center, big data center, fed into Orion, and Orion is continually thinking about how to optimize the activities of the fleet. So some of you will relate to this story. The first time that Orion came up with the optimal route for a driver, and they showed him the optimal route, because remember, the UPS pickup and delivery model is very difficult to achieve. They have deadlines for pickup and they have deadlines for delivery. and they're not all in the same place, and they're not all at the same time. So at the same time I'm trying to make a 10 o'clock delivery of an overnight package, I've got to go 3 miles down the road and pick up somebody else's package that's going to be delivered to another state, right? And I go on and on and on like that all day long. So it's a very difficult optimization problem. So Orion, the computer system that they've developed for many, many years, they delivered to the first driver the route that he should be following. His route that he's been taking normally is 150 miles. They handed him the Orion route and it was 140 miles. Guess what his reaction was? It's wrong, right? Absolutely. That's retarded. No computer could possibly tell me how to run my route better. So guess what he did? Tried to beat the computer, right? So he went out there and he did it in 135 miles. And he comes back and he says, see, your computer's wrong. I did it 5 miles an hour less than the computer, right? How many of you have switched from static response plans to dynamic response plans? Okay. Same problem, right? You go to the guys in the field and they see these fire trucks rolling by their station and they say, wait a minute, that's my jurisdiction. Why are you sending another fire truck? Because they think they're smarter than the computer. So here's the results, though, of this effort. They move 16.3 million packages per day, and they receive 39.5 million tracking requests from customers each day, right? You know how to do that. You go, well, where's my package, right? To date, they've accumulated 16 petabytes of data. Remember that big bubble chart? We didn't even get to petabytes. They're way up there. They're monitoring 50,000 vehicles in real time, braking, acceleration, engine performance, distance traveled. So far, in 2011, they saved 85 million route miles. They saved 8.4 million gallons of fuel, which saved them $30 million. Okay, just by optimizing the routes. There's also a bunch of side effects here where, because they're continually monitoring the vehicle's performance, they know when the vehicle's going to break down. So they no longer do preventive maintenance, they actually do just-in-time maintenance. And that saves them a whole boatload of money too. Okay? Well, wait a minute, we have all that technology, but we're not quite doing that, right? A different problem, we don't run delivery routes. Some of us actually do in the ambulance business for non-emergency calls. So, another interesting one is speech analytics. Is anybody in the audience using speech analytics today? Okay. It's interesting to me that we're not. I think this is something we really want to take a look at. Speech analytics is used very widely in other parts or other industries like retail, banking. So basically, using speech analytics, you can automatically transcribe every call, every customer interaction that you have. Very, very high degree of accuracy. They're experiencing using off-the-shelf analytics tools somewhere around 95+% accuracy on speech-to-text conversion. So what do? Well, in banking, they use it to monitor the interactions between the operator and the customer so they can sell the customer more stuff. Okay? So the customer's talking, they have a problem with their checking account, they're questioning a transaction, and they put 2 and 2 together and they figure out this person might be interested in a credit card. So up automatically on the operator screen says, pitch them on a credit card. And then if you have an unhappy customer that calls in, they can analyze the speech patterns of the caller to figure out if they're upset. So usually when we're upset, we talk really fast and really loud, right? So there's a good probability that they can know, just analyzing the speech in real time, whether or not the customer is upset, automatically sends a notification to the supervisor, you probably need to go get involved. Similarly, to enforce quality and training, they can analyze the operator's speech and figure out if they know what they're doing, right? If the operator has long pauses between when the customer asks a question and when they respond, what could that mean? They don't know what they're doing, right? It's like, hey, how come my computer is not working? Let me check on that, right? So very sophisticated algorithms that have been in use for many, many years to be able to help with those sorts of things. Now, it's, again, not obvious, right? Because we're not in customer service. Oh, we are in customer service, right? And you say, yeah, but we're not trying to sell them a credit card. No, you're trying to save somebody's life. So I see a lot of really good things here that we can take advantage of at some point in the future. Here's another interesting example. We've talked to this company a couple times. We just haven't figured the right link, but I think we're getting closer. So Inrix is a company that is a spin-off from a couple of guys at Microsoft. And they do real-time route optimization. So I think it's, is it Google, not Google Maps, MapQuest. MapQuest uses Inrix for their traffic information on the maps. So here's the problem. We tried to integrate to the DOT sensors a while ago so that we could optimize our routing. But the problem is the sensors in a lot of cases are highly inaccurate and very error prone. And they're not really that well deployed. So usually if you look at the sensors in the road network, where are they? They're on the freeways, right? They're not in town. So how do I get real-time traffic for in town? Well, they came up with a cool concept similar to crowdsourcing, where they contract with all these delivery agencies, and they track where those trucks go as they're doing their normal routing and delivery, and they feed all of their AVL data up into the Inrix cloud. So imagine a big fleet like Ford. Ford has a fleet, delivery fleet. All of those Ford trucks, as they go throughout their day, they're sending traffic information up to the cloud for Inrix. So that Inrix turns that right around and sends that out to anybody that's using their system, so you have right up to date real traffic flow information. Okay? Huge amounts of data, you can imagine, are going into this thing. All around the country and even internationally. The other thing that they do that's kind of cool is it's one thing for me to respond right now, and I'm going to say, I'm going to go send a fire truck to Coronado. Okay? Well, I know right now what the traffic patterns are because I have my Inrix system and it gives me real-time traffic flow, right? But what if I'm going to do that at 4:30 in the afternoon, or I have a delivery that's scheduled for way out? I want to get somewhere 3 hours from now. Well, that's not real-time traffic flow. But what the traffic routing algorithms do today on the internet is they use right now as the basis. Inrix has a modeling package that looks into the future based upon history to tell you what it's going to be like in 3 hours, not what it's like today. That's cool. So there's a lot of industries that are using big data today. Unfortunately, we are not one. So looking from left to right, this is sort of the adoption curve of big data. Education, retail, transportation, healthcare. Okay? We are here. It's not surprising. We lag normally behind because we don't have the budgets. But this is going to hit us, and this is big because it's big data, right? So the key in all this isn't to figure out how to get big data, because it's already there. The key is to figure out how to use it and how to visualize it. So what I need you to do while you're here and as you're going about your daily routine when you go back home is I need you to think about this stuff, and I want you to start thinking about the questions that you guys want to ask. Because that's really what big data is all about. This is a company called Sense Networks. What they do is they monitor device traffic in retail. That's San Francisco. So every time somebody goes and looks at something that has to do with buying something, anytime somebody goes to a restaurant, goes to a retail store, they track it and they create these retail maps. This way you can figure out, is my campaign working? I ran an ad campaign. Is it working? You can subscribe to this and you get real-time data to tell me whether or not people are inclined to come visit my location or not. So this is all about buying patterns, right? Guess where this data comes from? Twitter, Facebook, all the social networks. And it's all free. But you got to figure out a way to analyze it and visualize it, or you can't really figure out what it means. I don't even know what that means. But somebody thinks that's really important. Right? So let me ask you to think about some questions, okay? These are the ones that I could come up with, and I'm not in your shoes every day. So what impact did an officer have on his beat over the last week? Wouldn't you like to know that? How would you even define impact? Well, we can start to see it. If you look at the riots in Egypt, and you look at how they were started, they organized those riots over Twitter. Send out a tweet, everyone get together downtown, 1 o'clock in the afternoon, and they converge. If you look at when a major shift happens in a government, like Somalia, and you look at the Twitter feeds, you can see the connections and the activity before and as soon as the dictator is deposed, right? It's amazing. They're very real connections that have real impact in how you think about what's going to happen. I'm gonna guess that if you start looking at this stuff, you're gonna know in advance when things are happening in your community. You can also gauge like and dislike pretty easily, right? So there's a couple of agencies, this is one of my favorites, the BP oil spill. That's very relevant because they were talking about it today. They're estimating that they're gonna fine them with about $15 billion worth of fines to the government. So they did a graph on Twitter to see whether or not people were organized around disliking BP, right, after the oil spill. So they did a Twitter graph, and they could see that it was very active. A lot of people hated BP. There was a lot of traffic on Twitter about BP, but they weren't organized. So you could see, remember the graph with the people on it? There weren't hubs of people that have influence enough to drive a movement. So they weren't worried about it. They knew that just like the oil spill, the hatred of BP would evaporate over time. If you look at another graph, which is people that are interested on Twitter in solar power, totally different graph. Very concentrated on people that were activists. You could see the graph is very focused around hubs of people that are very influential. Okay? You get all that out of Twitter. That's insane. So, here's some other questions. We're evacuating people because of a multi-casualty incident. Is it working? Are they evacuating? Is the fire perimeter where we think it is? These are all things having to do with location, keywords, activity. We talked about riots. Can you predict a riot? Could you predict a riot from social media? I think you can. If you look at historically, it's true. Can you use voice analytics to study compliance of your call takers to protocol? Yes, I know you can, because they're doing it in healthcare now. Are they using the protocol that you established for them? Are there certain people that aren't? Could I use voice analytics big data to do that? I think so. So again, there's no shortage of data here, right? We just have to figure out how to use it. but I need your help. So again, corner me in the hallway, corner McAllister, corner the TriTech staff, and tell us what you think you could use big data for. Thank you very much. Have a great conference.